dispense with the distribution maps of dengue and chikungunya. So we have been discussing all morning and this afternoon really about the reasons for the emergence of dengue and chikungunya within the Caribbean region. And we have always been considering other forces rather than our own. And so really, we are the architects of our own breeding of mosquitoes. So we have to look at anthropological factors, including demographic changes which occur, for example, urbanization, the movement of populations from urban to rural and rural to peri-urban and to urban environments. And with them come a number of items, household items, plants, and other, and including animals and their dog bones, which may all have eggs of Aedes aegypti, and therefore they can bring the mosquito from the different parts of one country to another part. The second is the increase in land and sea transportation, and I think that has been really outlined today, and the Ebola story actually describes that quite vividly, together with the speed and volume of international travel. The third is the failure of Aedes aegypti program because of a lack of political will. We have heard everyone talk about politics and money, but what really makes a successful vector control program? It's the quality of the people running the program, the funding that is available, and also the support that's given by the community. There are also biological factors, insecticide resistance. I've heard people here doing presentations talking about pyrethroid resistance, and then and DDT resistance, and then quite surprised that there is pyrethroid resistance. It's the same sodium channel ions that are attacked by both the pyrethroids and by DDT. And therefore, the options become one of OPs and carbonates and IGRs rather than other pyrethroids. So we have to know the science behind insecticides and chemicals before we can manage programs. Infected vectors live longer. We are into climate change, and we are seeing the development of the immature stages taking a shorter period of time, and the adults are living a shorter period of time, and sometimes they live longer. So survival and longevity and the impacts of climate change is essential to the understanding of transmission of dengue and chikungunya. What about the change in size and the vector potential? We've been talking about intrinsic incubation periods. What has happened if the temperatures go up by a further 2 degrees? We are already experiencing 36 and 37 degrees Celsius in Trinidad. The nighttime temperatures will go down to below 23. As a little kid, it went down to 18. So we are dealing with in an environment that the temperatures are actually hotter, and therefore the mosquitoes, biological entities living within those environments, will therefore speed up its metabolism to cope, and therefore will do things much faster. But whether there are consequences needs to be studied. There are therefore the introduction of new and different strains. And here we're talking about chikungunya as an introduction of a new virus altogether within the region, of which everyone will probably 100% susceptible. And that's why it's raged like wildfire through most of the islands. But we've always been very lucky about vaccines, but unfortunately there are no vaccines. The quick fix, the magic bullet, is no longer there. And so we have to adopt new strategies. I have not heard one new strategy in all the talks, including the last talk, because there are lots of things. Now I'm talking about the cardinal points which you alluded to. So what are the factors which enhance disease transmission? The presence of suitable vectors, we know this. This is taught to everyone in medical school. Everyone in public health knows the presence of a suitable vector is important. The presence of the pathogen is important. The high density, so that those that survive long enough will be the vectors of the disease. Therefore, longevity is important. Immunological status of the population. Chikungunya explained to us what naive population, immunologically naive population is all about. And the role of reservoirs. Do we have reservoirs? Have anybody looked? So what are the current vector control strategies? Focal, perifocal operations. Same old, same consequences. You just change the chemical. Or you just change it, instead of tenephos, you put a monolayer and expect it to work. Space spraying, trucks, the aerial spraying. Do we get the penetration that is required to actually destroy the mosquitoes that are indoors? Do we get the penetration of the chemicals to actually kill mosquitoes within harborages or under houses and in the environment? Health education. A whole program was dedicated to health education and source reduction. And everyone speak about the actual breeding sites of the mosquitoes. Everyone knows. Yet they go on source reduction and remove the wrong things. The major producing sites are water drums and large water containers within Trinidad, Tobago, and some parts of the Caribbean. We need a targeted vector control program. Taking small pans and cans and bottles into a sanitary landfill dump is not reducing the population of mosquitoes. They do not produce adult mosquitoes. And even if they produce adult mosquitoes, they're so tiny that they may not be able to fly to actually take a blood meal. So, you know, I'm just telling you, why are these strategies not working? And it's definitely not working. Now we have these programs, and we have people that are talking about universal strategies. They think it's all over again. You know, we have one magic bullet that'll fix everything. Whether it's suitable or it's not suitable, you apply it. Well, if you're going to do that, you're going to fail. You know, some people actually believe that if you ignore the problem, it will go away. And it used to happen very often in epidemiology. We actually go to a problem after the peak in transmission has ended. And therefore there's a natural decline, whether you did something or didn't do anything. And so you tap yourself on the shoulder and says, great job, great job. A lot of people are actually talking about the media. The media gives us bad publicity. The rogue content of the media. Why don't we embrace the media? Let them help distribute, rather than publish pamphlets. CARPHA just did it. There is a publication in your packages where they got together with the University of the West Indies and they actually got newspaper people to produce a document that is suitable for this program and for this meeting. That's the example that rogue media is an outdated concept. Try to engage them. The use of the same approach and not expecting resistance. That's all I heard today. The same old, same old. And isn't that the definition of madness? doing the same thing and expecting a different result. Not adopting new strategies and a decline in community support. Are you surprised that you're not getting community support after 25 and 30 years of doing the same thing and asking the community to support you? I suspect that we need to redesign our communication strategies. One of the other issues is staff fatigue. Why is that important? You cannot have vector control people doing the same work for 30 and 40 years. There's a publication on dengue in the Caribbean, the outbreak of 1977. It was published in 1979 by PAHO. Many of the conclusions that you would find at this meeting is documented in that publication, 1979, where in 2015, 40 years ago, the same thing happened, but it was held in Montego Bay. And it had the same problems. But also we had a new dimension. We have now come to the era of the non-technical advisors. They advise people to do things which are expedient, which are good for making money. In 2012 and 2013, I actually warned about aerial spraying. They did not listen. I indicated to them about ineffective, it was ineffective due to a lack of penetration of the insecticides, which I said before, an increase in risk of asthmatics, the negative impact of insecticides on pollinators, butterflies, bees, birds, the negative effect of insects on aquaria fish, piggeries, chicken farms, the destruction of components of the ecosystem which we depend on to breathe, and the potential silent dawn, akin to Rachel Carlson's Silent Spring. Well, it didn't take very long. It was conducted, and it was conducted, I was told, to aerially spray the forest and water treatments for mosquito control. This is dengue control. Reports suggest that there would be need to continue. It was actually reported in newspapers. And I asked, where is the media? Where is the evidence that this thing is working? Well, the pollinators were killed, hives were destroyed, monkeys killed, and birds were killed in mass numbers. There were actual photographs in the newspapers. So I asked the question, who is responsible for compensating farmers and us, John Public? How do we undo the damage to the ecosystem? How many asthmatics were affected? Is making a profit the bottom line? This is the pattern of dengue cases over the past, from 1980 to 2011. And you can see that there were pretty good outbreaks of dengue in Trinidad. This I just wanted to show you. This is the outbreak of chikungunya in Mauritius. This is an example of the very close correlation between rainfall and outbreaks of dengue. And you can see it very clearly. This is the dry season. The dry season, the wet season, and the peak. The dry season, the wet season, and the peak. And then dengue just declined because I guess it was there was no more susceptibles around. Contrary to what you said, that this technique of pre-seasonal treatment was never evaluated, it was evaluated. I'm the inventor of it. So when we actually treated the location, we had a control and a treatment site. The control site continued to maintain a population of Aedes aegypti. However, the treated site, it actually reduced the number of mosquito eggs for at least 10 weeks, 9 to 10 weeks. And therefore, this strategy has now been adopted in Mauritius, and that's the reason why I showed you the seasonal patterns. Onto the other side, we look at roads as a barrier to mosquito movement and dengue transmission. We have found in our studies that the major roads, we have found that first-class roads, there are no dengue cases along first-class roads. 7% are found in second-class roads. 32% and 57% in third and fourth-class roads. And then the fifth-class road, there's a smaller one. So you can actually see a swath that where there is fast speed of cars, and very low speed and very close to the forest environment, there are very little mosquito Aedes aegypti and very little dengue transmission with those areas. With this knowledge, we then developed the diffusion model, in which we examine the dispersal of the vector and of dengue, looking at travel hubs as a site. The results explain the clustering of dengue and identified the travel routes. And there you go. From San Fernando in green to Port of Spain in the north, and then to Sandy Grande and Valencia in the east. Again, the dengue cases clustering among the travel hubs. This is when we superimpose the road network, it becomes even more clear. So transportation hubs and dengue clusters by year, you can actually see the movement from green to red to yellow according to the different years. So development of control strategies must not be a static one. It must be dynamic. It must actually take into consideration things that do not really just stay around houses. You have to expand your range and look at other areas for dispersal. So what were the results and the conclusion of that study? DHF cases clustered in space and time. That's why we got the clustering. During an epidemic year, the number of DHF cases increased and then decreased, showing a transition away from the epidemic. And DHF dispersal or distribution is correlated with transportation hubs, as indicated by large clustering around these areas. Now, so that tells us one thing. The second is that where do we find Aedes aegypti when we look at houses? We have done this, and you can actually see the majority of the female mosquitoes are in houses and in the bedrooms. 81.9%. 8.7% in living rooms. 6.0% in kitchens. The bathroom, 1.8%. And what is that telling us? It's telling us that strategies for the control of dengue and chikungunya, if Aedes aegypti is the primary vector, we need to start targeting inside houses, at least for that population. So what is the most suitable strategy to target inside houses? It's residual spray or spray spraying on the inside of houses. So we look for evidence-based public health. Here is evidence, and here is a strategy. The evidence of where the mosquitoes are found, and here is a strategy that could be implemented. So, what do we know? So I'll give you some more evidence. The blood feeding times, we know. The resting places, oviposition time, sugar feeding time, rest inside pre and post sugar feeding. We know where the rest indoors, the resting place outdoors, the resting place on the leaves and grasses, resting in dark places close to oviposition sites. We have this as a one picture that tells 1,000 words. I'm going to give you some of the new research that we have just done, and it is really sterile insect technique, which is a very interesting one because it costs nothing so far. What we did is to actually take a cobalt-60 machine, which is used for, you know what it's used for cancer treatment. But we do not treat cancer patients 24/7, from 8 to 4. So after that, we go in with our mosquito pupae and we radiate them at 45 degrees and bring them back into our laboratory at the University of the West Indies. And these are the experiments that we conducted as a proof of concept. The controls, which were not treated with any radiation, both male and females, produced 4,759 eggs with a hatch rate of 81.31%. The irradiated males and untreated females, that means they didn't copulate, and that's what you want in a SIT program. You want irradiated males to copulate with virgin females so that they will render them unable to fertilize, to lay fertilized eggs. So she did lay 3,879, of which 3,7 hatched. So we had a success rate of hatching of only, we had only 7.9% hatch. Irradiated males and males, on the other hand, we had only hatching of 3.8%, while irradiated males and females, which was on the opposite control, produced no eggs, 83 eggs, sorry, and no hatching. So this is therefore one of the strategies that is available to us. Now, these strategies are not new. They were started way back in the 1960s, but were stopped for reasons that became political with a number of assassinations and other reasons. I just wanted to show you this truck mounted as we go down to the end of the presentation. Look at this spray operation into people's face, I'm not sure whether it's closed or not. I think the shop is actually closed. The last one is the answer to the model for policy, because I think coming out of this will be a policy for the Caribbean and Latin American region. And according to the University of the West Indies, we use evidence to inform policy, and policy informs planning, and planning informs implementation. In this case, we need to embrace our politicians, and therefore I see Martinique did that. So we have evidence, we need to get the politicians and policy and then we go to planning and implementation. For without the politicians, there'll be no funding. And finally, so that's my message for people who would like to get some funding. And finally, I thank you. And I put this up because it's a place where I also live, and it's called a Tay Bridge. There was a disaster many, many years ago, but it's a constant reminder, if you do not keep vigilant, if you do not take heed of the construction and the wind and all the other conditions that can blow down a bridge, you can actually have a disaster. But it looks pretty right now. So let's keep it pretty, keep the Caribbean pretty, so that we can enjoy it in the future and not have a collapsed economy within the Caribbean region due to dengue and chikungunya. I thank you.